everyone. Welcome to our talk, Coprocessors, Uses, Abuses, and Solutions. I guess the first talk this morning of the HBase track. So my name is Esther. My name is Esther Kundin. I'm a senior software developer at Bloomberg. I'm the lead architect and engineer for the machine learning and text analysis team and an open source contributor. And with me is Amit Anand. He's a senior software developer as well on the Hadoop services and infrastructure team. He works with deployments and tooling for HBase, and he's also an open source contributor. And today, we're going to talk to you about HBase coprocessors. And in order to do that, we're going to first review a little bit of HBase architecture, which I'm sure you guys all know, but we're just going to go over it and make the rest of everything clear. We're going to talk about what coprocessors are and how they work. And then we'll talk about specific use cases of how you can use coprocessors, and then abuses and solutions, which are challenges that we faced and how we got around them for HBase coprocessor development. And then we'll talk about challenges and how we got around them in terms of HBase coprocessor deployments. Then we'll wrap up and leave you some time for questions at the end. So a quick overview of the HBase architecture. As you guys know, HBase is the Hadoop distributed big data store, and it's a NoSQL store, which means that we've just got keys and values, which are stored as blobs. We do not have any kind of inbuilt ACID support or any kind of type support or anything like that. And the way it works in general is that you've got all your keys, and the range of keys is partitioned into parts called regions, and then the process's region servers will serve those keys. So in our toy example here, if you've got 8 keys, which is 1 byte, you can partition it into 4 regions with 2 keys per region and assign 2 regions per region server. All very straightforward. And there are multiple processes running in the HBase system. You have your HMaster, which deals with table operations like table create, modify, delete. It deals with assigning regions to region servers. And we have the region servers, which actually are the ones that do the read and write operations for your data. And we have a special region server, the one that serves the .meta table, which maintains the mapping between regions and region servers. And it utilizes an outside system called Zookeeper to do the coordination between all these moving parts. So just a quick overview of what a HBase read looks like. If you have a client coming in, the client will first, on the very first request, speak to Zookeeper and find out where the region server that's serving the meta region is located. And then it will reach out there. It will tell it the key it's looking for and figure out which region server it should contact for that data. And then it will hit that region server, cache it for later use, and request the data. If the data is in the cache, it'll come right back. If the data is not in the cache, then it's going to hit HDFS, figure out which H file it needs to look at, read the data, pass it right back to the client. So on the right side, we have the same interaction in the beginning where we're talking to Zookeeper and the region server serving meta, et cetera. And then once it hits the original region server that is serving the region that the key is being written to, the first thing the region server is going to do is append to the write-ahead log. So this is standard database journaling. It's going to append that data to the write-ahead log. It's going to return at that point to the client saying that the write is successful because now it's durable. And then it will eventually write the data into the mem store and continue appending to the mem store. And then when the mem store is full, it will be written out as an H file onto HDFS. There will be compactions run off process, outside of this whole process to compact all these H files together. So now let's talk about coprocessors and how they fit into all this. So in general, a coprocessor is custom written Java code that, although it is written by the application developers, is actually run within the HBase process and the HBase system itself. So you would write your own Java code, you would compile the jar, and then you would load it onto one of the processes that we discussed earlier, either the region server or the HMaster, for example. So there are actually two kinds of coprocessors. We've got endpoint coprocessors and observer coprocessors. So the first kind is the endpoint coprocessor. These work more like stored procedures in the database world. So they're triggered when a client makes an explicit call to call this stored procedure. And they can do all kinds of computations. The canonical examples are things like average or summation, where you can push basically you're going to push your computation down closer to the data to speed it up. And in order to write it, you would specify the input and output of this, of the coprocessor using a protobuf, and then you would actually invoke the call. So again, this would just happen when a client invokes a call to the coprocessor, the computation will be done, passed right back to the client. The other kind of coprocessor is the observer coprocessor, and these are more similar to triggers in the database world. So in this case, rather than the client explicitly calling the coprocessor directly, the coprocessor will run when something happens in the ecosystem. And there's hooks available for almost any kind of HBase event type. So the canonical example for the use of a coprocessor is something like a security check. So if you wanted to check a user's permission before they do a read or a write on the data, you can actually hook into the pre-get op, for example, for a get, and check the user's permissions via an outside security system, see if they're allowed to read the record, and only then retrieve the data, otherwise fail the request. Same thing for the put. You can do a pre-put, and you can have your coprocessor check whether the user is allowed to write to this table or not before passing the data back. The other uses that you can do with your data are things like referential integrity, where if you wanted to maintain your own second table and you want to ensure that there's foreign key constraints, you can actually check before the write that the key exists in your second table and maintain things like that. And you can also build things like secondary indices, where you can build a second index on your data, and then whenever you do a write into your data, you would actually do a write into your index that will be indexed by a column outside that is not your key. And this is exactly what Phoenix does. They are basically putting out coprocessors that handle things like referential integrity and secondary indices. And at the bottom of this slide, what you have is kind of what the data flow looks like, where when you're reading data, for example, from HDFS, the data will pass through your region server, and it will pass right through your coprocessor jar, which is written by your application developers, and only then pass to the client. So the other thing to mention is that there is support for filters in HBase. These are very similar to the observer coprocessors we were talking about. They were built into HBase at an earlier time, and they're a little bit more limited than a normal coprocessor. What they only let you do is things like gets and scans, and you can then filter this data so that you pass back less data, and you can run predefined operations on the data, or you can actually deploy your own custom filter and run it over the data. So this would work very similar to the way the coprocessors work, where you're writing your own jar that is then running within the HBase system. However, they're a little bit more limited in that they're really only running on the gets and the scans. So just to show you an example, this is taken directly from the HBase book. If you were to write your own custom filter class, that jar would get deployed onto your region servers, and then you would be able to call your custom filter class directly when you're doing your HBase call, and then pass a predicate to work with your filter. So observer coprocessors are much more powerful than filters. They allow you to hook it into many other operations. So there are hooks for region server observers. You can run them when you start and stop regions, when you execute other procedures, when there's compactions going on. The typical examples are things like pre-get-up and post-get-up, pre-put, post-put, which are a little bit more similar to filters. And they can run on actions on the write-ahead log, like when the log file is rolled or is written to. They can also run on the HMaster process, not just the region server process. So they can be run before or after table creation or delete, or when snapshots are being done, regions are split or reassigned, and many more. So again, any operation that HBase does as a whole, there's a hook in the coprocessors in order to do your own custom job there. So let's talk about one of the uses of coprocessors, which is some of the work that we've done. Just as an example, so you can use the coprocessors to control behavior of the region servers, as we've talked about, and you can use them to control data operations. So in general, you can do server-side processing, like the filtering and the aggregates, and the reason to use something like this is that it could reduce the pressure on your client and on your network. So for example, if you wanted to do some calculations over your data set, you can pass all the data back to the client and then process it, or you can push the calculation down to the actual HBase coprocessor, figure out what data you actually need rather than the data that you don't, and then you'll be passing less data back over the network, and you'll be doing less work on the client as well. So the one thing that you have to remember is that you don't want to do anything very, very complex in the coprocessors because, again, this is going to be a recurring theme. The jars are running within the HBase processes themselves. So anything that you do that takes up a lot of time or memory or anything like that is going to affect the whole system for everybody. So you need to be very careful about what you do and do not do in these coprocessors. If you're going to be doing very advanced analytics, we do suggest using something like Apache Phoenix, which was tuned to do things like that. So getting back to our toy example here, suppose we needed data from the region and we want to get a bunch of data. So we can run a post-get operation that does something like this. So imagine we have 3 keys of data and they're have some holes in the data streams where the columns are missing. And what we really want to get is a waterfalled version of the data. So we want to get basically key 1, and we don't care where the data came from, and we want to see it waterfalled. So for example, for the first column, we want to see the 1 because it's on top. For the second column, there's a missing data. There's a hole in the data, so we want to see the 2. Next, we want to see the 4 and the 5, and then for the last column, we want to see the 12. So we really just want to see one stream of data, but because we're missing a lot of data, what we had done previously would be to get 3 streams of data and then combine them on the client side. So again, the client has to do all the combinations, and we're passing back a lot of data that we don't actually need or want to see at all. So this is a really good candidate for a coprocessor to do this work for us and then send a lot less data back to the requesting process. Just to mention here, definitely because this is HBase and PhoenixCon, Apache Phoenix works over coprocessors as well. You cannot have Apache Phoenix without coprocessors. They're supporting full database operations over HBase, and they're doing that by running coprocessors within HBase, and they were doing foreign key constraints. They are doing secondary indices for you, and they're doing a lot of push-down analytics similar to the example on the previous slide where they're trying to balance between doing work right on the region server side and then on the client side. So a lot of what we're talking about is really important for not just your own projects, but other projects like Apache Phoenix. So now, the interesting part, we're going to talk about some of the issues that you can face when you're actually using coprocessors day to day. So as a developer, one of the main issues that you see right away when you roll out coprocessors is that exceptions are very, very bad. If your coprocessor ever throws an exception, again, remember, your coprocessor is running within the HBase process. So there's only 2 options. Either it's going to throw the exception and take the entire region server down, and then when the region server is down, all the regions that are assigned to that region server are now completely inaccessible. And in the time that it takes for Zookeeper to figure out that the thing is down and then HMaster will need to reassign it, in that time, all the data served by those regions is now completely and utterly inaccessible to your whole system. So you've just done basically a major outage. And the other way that your system could be configured is rather than bring down the region server, it will just silently unload your coprocessor. At that point, your all your regions are available, but the data you're getting is actually silently not running your coprocessor on it, so you're getting wrong data without realizing. Both of these scenarios are really pretty bad. So throwing an exception in your coprocessor jars is a very bad idea. So the solution that we came up with is pretty obvious. You got to catch all your exceptions. In fact, what we ended up doing is writing an interface that will always catch and log everything, no matter what happens. And the only coprocessors we're allowed to roll out are things that inherit from this kind of interface to make sure that we don't get into the scenario where we're bringing down region servers or silently failing without telling anybody about it. Another issue, again, stemming from the fact that you're running your jar within the HBase region process is if you're hogging memory. Again, it's all one process. If you're going to start hogging memory in your coprocessor, then there's no memory left for caching or anything else that will make HBase work. And especially if you're in a multi-tenant environment, you're not messing things up just for your process, you're messing it up for anybody else that's sharing this cluster with you. So the solution there is, again, you need to write your defensive Java code. Everything needs to be reviewed. You got to profile everything that you do. You should use something like JProfiler or some other Java profiler to make sure you're not wasting a lot of memory. And you do standard Java tricks like using primitive types and underlying arrays. You don't use object types. You try to use immutable objects, string builders versus concatenation. And very standard thing is just to try to make sure that you keep your memory usage as low as you possibly can within your jars. Finally, logging and metrics are a bit of a challenge in this environment where everything you log is, again, going to HBase logs and nothing separate. So we found it really important to use a log4j properties file and log everything in a coprocessor under in a completely different place, so it's easier to find. We also found that using an MDC, the map diagnostic context, was really useful in terms of being able to pass parameters around and being able to tell when one request comes in and it's running multiple coprocessors, like a pre-put and a post-put, for example. We can then figure out that it's the same request across multiple calls and then logging everything appropriately. And the other trick that we figured out is it's really convenient to take all the diagnostics that you run, timers and other statistics that you want to collect, and then pass them all back as a secret row, a secret column appended to your row in the data you're passing back. And then that data will then be available to the callers, and you can do other things with it, like logging, and other statistical gathering. And now for the second half of the talk, I'm going to pass it over to Amit.
Thank you, Esther. That was some excellent information, and you did excellent on the time. Yeah, thank you. So we'll start with deployment of coprocessors. So deployment of coprocessor in HBase is known as coprocessor loading, and there are two ways you can load your coprocessors. One is the static loading, and the other one is dynamic loading. There are three key properties in HBase that control loading of the coprocessor, static loading of the coprocessor. Those are HBase coprocessor.region.classes, HBase coprocessor wall.classes, and HBase coprocessor master.classes. And these are specific to the type of coprocessor you're developing. The region.classes property is for region observer and endpoints. Wall.classes is for wall observer, and master.classes is for master observer. So depending upon the type of coprocessor you're developing, you modify the property accordingly, and then you update your HBase site XML. In the example on the slide, I have an endpoint coprocessor, and that's why the property I modified here is region.classes. So once you modify your HBase site XML, you must deploy that file on every single region server, and you must restart your region servers. So once you do that, your coprocessor will be loaded in HBase region server memory. Some of the key points to remember: when you statically load a coprocessor, they are active on every single region server, and they're available to all the regions of all the tables. That means any table that is deployed that is created on HBase can take advantage of code written in the coprocessor. You can also deploy multiple coprocessors, and you need to provide a comma-separated list of your classes in this property that was mentioned in the previous slide. Then you copy your jar file, coprocessor jar, to HBase zip directory. That is the default location for deploying any jars. Or if you have a separate location, then you must update your HBase environment shell script to include that into the class path. And finally, you must restart every single region server. There is another property in HBase that is hbase.dynamic.jars.dir, and that property is not for coprocessors, that is for filters. To unload a coprocessor from memory, so the process is pretty simple. You just remove the properties from HBase site XML, or you remove the classes from the configuration. Again, you update your HBase site XML and deploy it on all the region servers. So once that is done, you must restart your region servers, and the coprocessor will be unloaded from memory. The next is dynamic loading. So dynamic loading is pretty simple as compared to static loading. You do not need to modify your HBase site XML, and the loading is per table basis. What does that mean? When you dynamically load a coprocessor, you are basically attaching it to a single table, and it is only available to that table and all the regions of that table. And that is why they're also known as table coprocessors. For dynamic loading, you can use HBase shell, or you can use Java APIs to attach a coprocessor to your jar. And usually in dynamic loading, the jar is deployed on a shared location, and usually that is HDFS. And that's a preferred method at Bloomberg for loading coprocessors, because we don't want to restart clusters every time we deploy any jar. So in this picture, basically there are two coprocessor jars that are copied onto HDFS, and they are loaded using HBase shell. The first thing you need to do for dynamic loading is you disable your table. It will definitely make your table unavailable for the time being, and then you issue an alter table command, and there's a method in HBase called table_att. With that, you attach the coprocessor to your table, and you specify the class name as well. And finally, you enable your table, and after that, you can verify that by running describe command to see that your coprocessor is attached to the table. If you're a Java developer, then you can use admin and htable descriptor APIs, and there is a method in htable descriptor called add coprocessor, which will allow you to attach the coprocessor to your table. To unload a coprocessor dynamically, again, you disable your table on HBase shell. Now the method is table_att unset instead of table_att, and you specify the name of your coprocessor, and finally you enable the table, which will detach the coprocessor from your table. Again, through Java, if you're a Java developer, then you can use remove coprocessor from htable descriptor. The example is from HBase documentation, which is using an old API. So a comparison between static loading and dynamic loading. So if you're doing static loading, you have to modify your HBase site XML, and in dynamic loading, you don't need to do that. If you're doing static loading, you must restart region servers. Only then the coprocessor will be available on the cluster. For dynamic loading, you don't need to restart your region servers, and the moment you attach to a table and enable a table, it will be available immediately. For static loading, the jar location is local file system. So other than modifying your HBase site and deploying it on every single node, you also need to copy your jar on every single machine on the same location, so that when region server restarts, it can pick up the jar from the local file system. For dynamic loading, the location is usually HDFS. Availability-wise, static loading is statically loaded coprocessor are available globally. That means they're available to every single region of every single table on the cluster. On dynamic loading, since they're attached to a single table, they're only available for that table. You cannot statically load the coprocessor using HBase shell or Java API, and dynamic loading would let you do that. In both the cases, the HBase user must have read permissions on the coprocessor jar, otherwise your cluster will come down to halt and you will have to recover it manually. The management complexity is extremely high when you're doing static loading, because you have to modify your HBase site XML, you have to deploy that file, you have to copy your jar on every machine, you have to restart region server, which will break the region locality, because when you're restarting your region servers, the region will move, and then your locality is broken, and you need to run major compaction to fix that. But while dynamic loading, you don't need to, the complexity is very low, because you're not restarting your cluster and there is no region transition. So some of the challenges with deployment. So the biggest challenge is version compatibility. So if you are a cluster administrator, you tend to upgrade your cluster as soon as there is a new release, when there are bug fixes, to have a stable version of HBase, but your developers may not be ready for that version because their application is already stable, they're working with a version that they have tested very, very well, and they don't want to go to the new version because they have to go to the entire testing process again. So that makes it a little tricky. So as an administrator, you must work with your developers to make sure that their code is always compiled against the latest version or the version that is running on the cluster, so that there's no compatibility issues between server and the client side. If there's any compatibility issue, the rollout of non-backward compatible coprocessor is difficult. It requires manual intervention, and then it takes like time to recover the cluster. There is an HBase Jira 14190, which is still open actually. Right now, HBase assigns tables in random order. It does not give any priority to system tables, and this Jira talks about that. So some of the solutions for that is the developer should compile their code against the version deployed on the cluster, and you should always work with your developers and review their code 10 times. Never trust them. So in static loading, the deployment is controlled by administrators because they are responsible for modifying HBase XML deployment of that file on the entire cluster. But with dynamic loading, the users can deploy the coprocessor by themselves, which is very dangerous. So to give an example, I was working with one of the application team, and we have a deployment process which is automated, and we use Chef for that. So that also includes onboarding of all the users, which involves creation of their user directories on HDFS. So when we create the directory, there was a bug in our code, which after initially creating the directory, never checked for permission on that directory. So users were able to go and modify the permission on their user directory and do whatever they want, and our code would not do anything. So what they did, they basically created a coprocessor jar, they copied it onto their user directory, and they changed the permission of their user directory to 755 and made it world readable. Now HBase can read that jar, and they attached the coprocessor to their table, and everything was happy for them. And we discovered a bug in our code, and then we fixed that, and we deployed the release, which basically now checks for permission every time we run the code, and it resets the permission to 700. Now HBase can read the jar, it will bring down the cluster immediately. The cluster crashed, and then we were debugging what's going on because HBase could not read the coprocessor jar on HDFS, and that's why it crashed the entire cluster. So there's a property that controls the crashing of HBase region servers. The property is hbase.coprocessor.abort an error. So we set that property to true. So there's a debate on that, whether you wanted to set that to true or false. If you set that to false, the coprocessor will be unloaded. Then you don't get the desired result, as Esther mentioned. But if you set it to true, it will crash your region server. So it's a chicken egg problem. What you want to do with that? Do you want to crash your region server, or do you want to get incorrect data? So when that happens, again, bringing up the cluster is challenging because the location is now not accessible by a region HBase user, and you have to basically restart the cluster because region server is down, and the moment you bring up a region server, it will try to read the same location. It won't be able to do that, and it will crash again. So that requires manual intervention. You have to go and remove the table from HBase by removing the Z node from Zookeeper, and that's how you recover the cluster. So one of the solutions we implemented in Bloomberg is create a common shared directory, and we did that by creating a directory /HBase, which is readable by HBase by default. And then you use some kind of automation to deploy user coprocessor jar to that location, and don't give them access to this location. So some of the deployment guidelines. There are two core properties that basically control the enablement of your coprocessor. One is HBase coprocessor.user.enable, and you must set this property to true, because if you set it to false, it will also disable the Phoenix functionality. If you're a Phoenix user, Phoenix coprocessors are also treated as user coprocessors, so there's no distinction. They're not treated as system coprocessors. So if you set this property to false, your Phoenix functionality will be completely unavailable. Similarly, you have HBase coprocessor.enable that is used for system coprocessors, and some of them are like access controller if you're enabling Kerberos on your cluster, or there's bulk endpoint. So all those coprocessors will be disabled if you set this property to false. There's a Jira HBase 6700 that one of my coworker worked on. So this is again a coprocessor basically to whitelist other coprocessors. So it runs as a coprocessor as a master observer, and it watches for any alter command that you issue against your table, and it makes sure that when you're altering and attaching a coprocessor to your table, the path that you're specifying is listed under the whitelist path. So you set this property, you specify the path, and then after that, any user who's trying to attach a coprocessor will not be able to attach a coprocessor if it is not listed under whitelisted path. So there are some challenges with that property. So the documentation says you can specify the entire file system, which means HDFS, like test laptop, is the file system which we have. You can do that, and it will pick up the jar from any location under that. That doesn't happen actually, so don't trust the documentation. And recently, I discovered another bug with this Jira. So it only watches the first alter command. So in the very first path that you give in the alter table, it will restrict that from not getting attached if it is not whitelisted. But after that, you can attach any path. So some more guidelines here. If you're doing static loading, it is recommended that you create a bundled jar, and so that you have only a single jar for multiple coprocessors, and you only have single entry in your HBase class path, and you only and that's how you basically make it easy for you to deploy your coprocessor. Definitely use some kind of automation, whether Chef, Puppet, or Ansible, and there's a chart of some of the key properties that you should be aware of when you're deploying your coprocessors. Some of the takeaways. So coprocessors are very necessary, especially like for functionality like Phoenix and HBase security, and they also add a lot of power if they're done right. So, but user coprocessors are dangerous. So make sure that if you're an administrator, you're working with your developers and you're verifying their code 10 times. Otherwise, you will be getting a call in the middle of the night that cluster has gone down, and you'll be waking up and fixing the issue that you have not created. And also be careful with deployment. If you make any mistake in the deployment path and all that, then it will crash your entire cluster, and then you have to, again, get up and fix the problem. And definitely make use of HBase 16700. That will definitely help you and save you a lot of headache. Few things that is needed from community. Better story for coprocessor deployment. And the most important is process isolation. Right now, the coprocessors are loaded in HBase region server memory, and so they're part of that memory, and they put pressure on that. So whenever they throw any exception, as Esther mentioned, they will also impact the availability of the region server, which means your entire cluster is down. The moment your one region server goes down, it will propagate to the next one, because region will go to the next region server, that will come down. It will propagate to the next one, that will come down. So it's an avalanche effect, basically, which will bring down your entire cluster. Finally, we need some better metrics on coprocessor usage so that we understand behavior of coprocessor in a much better way. With that, thank you, and we are hiring. If you're interested in working with us, please feel free to go to bloomer.com/careers, and I would like to open up the floor for questions now. You have 7 minutes. Thank you.
What are the use cases for coprocessors? Like you mentioned, aggregation is one, but internally, what kind of other do you use for security?
So the question was, what are the use cases for coprocessors? So the project that I worked on was the use case that I mentioned, where we were waterfalling the data. So it's kind of, I guess, like a custom filter, but not exactly. We were basically, we had multiple streams of data, but we only wanted one full stream. So the waterfalling process of the data was run on the coprocessor, and then we could send back a lot less data, and it would run a lot faster because we were also requesting multiple fields multiple rows at a time. So we can distribute that computation across the whole cluster rather than running it on the clients. I think for the observer coprocessors, it would be the same thing. If you wanted to run a larger computation across all your data, it would also be much more efficient than running like a scan, for example, and then kind of walking through it record by record.
So instead of reading all the data from all the regions, getting it back on the client side, you push the calculation on the region server itself. So you only get the limited data back that you want.
So in general, any kind of like push down analytics work really well with this.
Yep.
So you said there's been a lot of interactions between your team and the customers or developers. Do you have a model where your team says we got enough resources to work with developers to go through all the processes that allow things to get onto the cluster and things like that? So do you have a developer versus admin team developer model where you got enough resources to actually work with them?
The question is, do we have a model to have a coordination between developers and administrators? And yes, we do. So we run multiple clusters in Bloomberg, and our team that manages those clusters is divided in a way that if I'm an administrator, I'm responsible for a certain number of clusters, and I know all the clients that are working on those clusters, so I work with them all the time. So whatever work they're doing, I'm continuously in touch with them, and I'm making sure that whatever they're doing is not going to break my cluster. So I have to work with them, and they have to work with me whenever they're making any changes on the development side, especially with the coprocessors. So I review their code, and then my entire team reviews their code, and we make sure that it's not going to break our cluster.
How many developers?
In our team, in the administration team,
Whoever writes the code.
so that is on the application side. So we work with like maybe hundreds of application teams. There are so many. And so we have like dedicated clusters where only one team is there. Then we have multi-tenant clusters where we work with like multiple teams.
I think that's also what makes this presentation compelling, because I was on the developer side, so I gave the developer perspective, and Amit was on the support side, and we definitely worked together in order to get this done. And yes, I did need to, things that I learned were then passed on to other developers, and then as well as to the deployment side. And then we do try very much to share best practices among all the developers, so that things like this that I've learned, I'm talking to the other developers on the other teams. We're trying to make this the best practice for how other teams will deploy their own coprocessors.
How many admins do you have on your team?
Can I mention that number? I'm asking my manager here. We have few of them actually.
Repeat the question.
So the question is, how many admins do we have in our team? So we have a bunch of admins, and I think all of us play multiple role. And there's a lot of, so I think all of us are willing to contribute to open source. We go and read open source code all the time. Whenever we run into any issue, the way we work is we dig deeper into the problem, and we directly, if we like look into the logs and all that, then we go into the code. So most of the admins are familiar with Java code as well. So that's how we are able to work with our developers.
What version are you guys using? Because you mentioned that some of the examples you put up were on older versions. Is that?
In those examples, so the question is, what version are we on? So we are on HBase 1.2, and the examples are from HBase documentation. That's where they're older version. So we were not allowed to copy and paste our code onto the slides.
Yeah, but I mean, it's supported from, I think, 098. I've worked with 098 on. So most of the issues and things that we've mentioned carry on throughout all the versions, although I don't know anything about 2.0.
Yep.
How do you manage dev clusters versus production clusters?
How do we manage dev clusters versus production clusters? I think the process is pretty much the same, and we consider our dev clusters as prod as well. So we have some clusters that are not even there like before dev. So any release that we do, so our code is all automated to deploy and manage these clusters. So that release goes on to those environments first, which are pre-development, and all the tenants are required to run their application on that cluster as well, just to make sure that whatever release we are pushing is not going to break them. So once they give us a go-ahead in a couple of weeks, then we move to the next environment, which is development, and then to QA, and then to prod. But the process is pretty much the same to manage all the clusters. So they break the cluster which is before development. That's where they break it. We call it junior. That is the actual name of the cluster. It's a junior cluster. No, junior, dev, QA, and production. So before they break the production environment, they have to go through 3 different layers, and we cache them. And even before on junior, they have to work with us to deploy their code. How long does it take to write a line of code to?
Administrative code or developer code? Developer code is actually pretty quick because these clusters are all there. So you can do it.
We do actually, yeah. The only time we take is junior cluster takes a little longer because we want to make sure that all the tenants are okay before we push a new release. But after that, once they're okay on that environment, it's pretty quick to move to. And what all we do, it's just all automated process. We don't do anything manually. So we just have to like make changes to our GitHub repository, and the changes will be picked up and they will be rolled out automatically. So we will not push any changes to any other cluster until it is tested on junior environment. So
We have that. You can work with a sandbox environment, but it's very limited and there's no data on it. So there's not that much you can do to break things.
So
Usually it takes bad data to break things.
Yeah. And so this on the previous slide, let me go back. There's a link on the previous slide if you go. So github.com Bloomberg Chef Bach, that's our open source project, which we use internally as well to deploy and manage all the clusters. And if you download this, you can build a 3-node cluster by default, which will give you an HA environment, and it will be secure. So which is pretty similar to what we run internally. We definitely have some internal hooks, like some modification to configurations and all that, but the rest of the code is pretty much the same for deployment. So if any developer is willing to, if they don't want to do something on the junior cluster and they want a dedicated cluster, they can use this code base to build a VM cluster, which is vagrant, and they can test their functionality. Yeah.
How do you measure the impact of deploying new coprocessors on production? Like you have multi-tenancy. So there are no metrics. We are like in a black hole there. Like how you figured it out that they work or not, like without impacting other workloads?
Yeah. So one thing, that is why we do table level coprocessors. We don't do static loading. So the question is, how do we basically make sure that whenever a new coprocessor is deployed, it is not going to impact other tenants in a multi-tenant environment? And so the answer is the reason we only allow table level coprocessor, which is dynamic loading. So dynamic loading is only for a single table. If it is going to break anything, that will be that table only, and that too after a lot of reviews we do with the developers. So if we do static loading, then it is impactful to all the tables, which we don't do. We don't allow any static loading on our clusters.
So basically, you see something is breaking out, disable the table, forget about it.
What is that?
You disable the table and forget about it, you roll back the coprocessor.
No, we don't disable. If there's a problem, yes, then we have to do that. But that problem is like, we know of that problem in the junior environment. We test that very rigorously in junior environment. The developer code goes through a rigorous process of review and all that before we try to like run all kind of tests to make sure that it's not going to break the cluster. It can still happen. It's like code, but we manage that very well. I think we're running out of time now. Okay.
Do you run multiple HBase clusters, dedicated workloads, or do you run your HBase cluster on an already busy Hadoop cluster that's doing other things, or?
We have multiple clusters. So there are dedicated clusters for like specific applications, and then there are multi-tenant clusters which are like shared by multiple teams. So we have all kinds. So we have like tens of clusters.
Thank you.